On August 6, 2025, the James Webb Space Telescope slammed into emergency mode to capture an object that really, honestly, shouldn't exist. Astronomers, including the Pan-STARRS team in Hawaii, expected a dying ball of ice. Instead, Webb's new data on the interstellar comet 3I Atlas just confirmed a chemical nightmare. This visitor isn't just unusual, it's breaking every rule in the book, and the deeper the data goes, the more unthinkable the questions get. Let's explore this together. Emergency override, Webb's unprecedented response. What does it take to stop the world's most powerful space telescope dead in its tracks? On August 6, 2025, we found out. When the alert came from the Pan-STARRS survey, led by principal investigator Ken Chambers, the numbers were alarming. The interstellar object 3I Atlas was accelerating, its spectrum flashing with unexpected metals. There was no time for committees. In a move almost unheard of, a director's discretionary time override was triggered, sidelining Webb's entire multi-million-dollar schedule. This wasn't a normal target of opportunity, this was an emergency. The command chain went straight to the Space Telescope Science Institute director's desk, requiring unanimous approval. It was a massive risk. A single unscheduled slew of that magnitude can cost over 12 hours of precious observation time and risks thermal shock to the delicate mirror segments. This time is meticulously allocated to dozens of other research teams who have waited years for their shot. At 2:17 GMT, after a rapid 38-minute repointing maneuver, the command went live, the tension palpable in the Baltimore control room. Webb's instruments locked onto an object that was already beginning to rewrite cosmic chemistry. Fewer than 4 such overrides have happened in Webb's entire operational history, none for an interstellar object. Early activity beyond Jupiter's orbit. Here's the first red flag, that 3I Atlas was no ordinary comet. It woke up in the deep freeze. Most comets are quiet until they cross inside the solar system's frost line near Jupiter's orbit, roughly 5 astronomical units from the Sun. But 3I Atlas was already active at 6.8 AU, far out where the Sun is just way too weak to sublimate water ice. Ground-based telescopes, following up on alerts from observers like Karen Meech at the University of Hawaii, noted a persistent brightening of 0.3 magnitudes in just 48 hours. For an object this distant, that represents a massive increase in its gas and dust output. This sustained activity, producing a tenuous coma when the surface temperature was below 150 degrees Celsius, pointed to a body born in a place fundamentally different from our own solar system. Its engine had to be a hyper-volatile ice, something that turns to gas in the slightest warmth of the distant sun. The comet's tail grew at a pace that stunned the teams watching, driven by gases that simply shouldn't have been active so far out. It was the first clue that the chemistry of this visitor, as cometary expert Michael Mumma might put it, was deeply, profoundly wrong. The carbon dioxide anomaly. When Webb's near-infrared spectrograph delivered its first data packet, the anomaly was impossible to miss. The absorption band at 4.26 microns was breathtakingly strong. It's the classic textbook signature for CO2, and it utterly dominated the spectrum. The final analysis confirmed a carbon dioxide to water ratio of 8:1. That isn't just an anomaly, it's a statistical impossibility based on every comet we have ever studied. For context, even the most CO2-rich comets in our system barely reach a ratio of 0.3. The gas production rate was staggering, calculated at over 1.5 times 10 to the 28th molecules per second, an output comparable to what the great comet Hale-Bopp produced when it was much closer to the Sun. Every cross-check from Hubble and the Keck Observatory confirmed it. This isn't a calibration error, it's a message, as a planetary scientist like Stephanie Milam at NASA would argue, from a star system where the chemistry of planet formation was completely inverted. Such a system might have formed around a carbon star, creating a world where carbon dioxide, not water, is the dominant ice. Nickel without iron, an impossible chemistry. You know, this is where the story goes from strange to deeply unsettling. As the team at the European Southern Observatory analyzed the high-resolution spectra, they found clear emission lines for atomic nickel at 3,415, 3,524, and 3,525 angstroms. But the real shocker was what was missing: iron. In every celestial body ever studied, Nickel and iron are chemically inseparable, forged together in the hearts of dying stars and scattered in a cosmic ratio of about 1 part nickel to 15 parts iron. Yet, even with the Very Large Telescope's UVES instrument running at a resolving power of 80,000, iron was a ghost. The data was brutal. The upper limit on iron atoms meant nickel outnumbered it by more than 40 to 1. Spectroscopists like Neil Dello Russo at Johns Hopkins would confirm this is unprecedented. The only plausible, though exotic path is the molecule nickel carbonyl, which is so volatile it vaporizes at just 43 degrees Celsius. This molecule is extremely fragile and would break down under solar radiation, releasing the free nickel. But for that to be the explanation, the object had to form in a place that chemically isolates nickel on an industrial scale, a process unknown in nature. Trajectory anomalies and acceleration spikes. As if the chemical puzzle wasn't enough, the way 3I Atlas moved was just as bizarre. Davide Farnochia's team at JPL, who are masters of celestial mechanics, flagged its trajectory before the Webb data even came down. The object wasn't just following the clean arc of gravity, it was accelerating. Over a 72-hour period, its velocity increased by nearly 0.12 meters per second squared, a non-gravitational push far beyond what the observed outgassing could explain. The thrust calculated from the gas production rate was an order of magnitude too low to account for the observed change in speed. The data also showed tiny sharp jumps of up to 1.5 meters per second, as if an internal force was flickering on and off, rather than a steady, continuous jet. This stands in stark contrast to Oumuamua's smooth acceleration. For an 11-kilometer-wide body with an estimated mass of over 1 trillion kilograms, this erratic push is like watching a mountain suddenly lurch forward with no visible cause. The physics just doesn't add up. The acceleration was real, and it wasn't coming from ice alone. The lighthouse effect, mechanical light curves. Every object in space tumbles, but 3I Atlas's light curve is anything but natural. Photometric data from NASA's TESS satellite revealed a periodic brightening that pulsed with the precision of a clock, sweeping like a lighthouse beam every 7.2 hours. A tumbling potato-shaped rock would produce a smooth, rolling sine wave of light. This was a square wave, ramping up in brightness by a full 1.8 magnitudes in just under an hour, holding steady, and then dropping off sharply. This implies an object with distinct flat sides and sharp edges, unlike the irregular shapes of natural bodies. Furthermore, outgassing should create torque, causing the object's spin period to change over time. Instead, the 7.2-hour period remained locked in to within 1,000th of a second, a major physical contradiction. An expert on exoplanet light curves like MIT's Sarah Seeger would immediately recognize this as unnatural. The sharp increase in brightness also hints at a highly reflective, possibly metallic surface being periodically revealed to our line of sight. Ancient sky metal, historical context. You know, the idea of strange metal falling from the sky is really woven into our oldest histories. Around 3200 BCE, ancient Egyptians hammered beads from iron they couldn't have smelted. Discovered at Gurze, analysis shows they are nearly 30% nickel, a cosmic fingerprint proving they were made from a meteorite. Centuries later, a dagger was buried with Tutankhamun around 1323 BCE. Its untarnished blade contains 11% nickel. The Egyptians called this material Baya and Pet, or iron from heaven, with a hieroglyph combining sky and metal. Further afield, the Inuit of Greenland used the Cape York meteorite for centuries as a source of iron for tools and harpoons. As historian Lydia Baum of Heidelberg University notes, these cultures knew this metal was not of the earth, it was a gift or a warning from the gods. This ancient reverence for rare, otherworldly materials, well, it mirrors the intense scientific focus on the anomalous metals being broadcast by 3I Atlas today. Avi Loeb's challenge to consensus. You can't have a conversation about interstellar anomalies without Harvard astrophysicist Avi Loeb. When the data on 3I Atlas came out, he immediately argued in a new preprint that these are all potential hallmarks of something engineered. In the lab, separating nickel from iron is done via the Mon process, which eerily uses carbon monoxide to create volatile nickel carbonyl, the exact chemistry hinted at in the comet's coma. Loeb argues that while the community scrambles to invent exotic natural comets, we must apply Occam's razor. Is it simpler to invent new astrophysics? Or to consider an existing category of object we've theorized about, technology? His critics rightly say extraordinary claims require extraordinary evidence. But Loeb's position, now supported by his Galileo Project initiative, is that the evidence is already extraordinary. The project's mission is to actively search for technological signatures, and 3I Atlas fits the profile of exactly what they are looking for. Clinging to familiar explanations when the data screams otherwise is a failure of scientific imagination. Scientific community divided. The revelations about 3I Atlas have sent shockwaves through the astronomical community. On one side, scientists like Michelle Bannister of the University of Canterbury are pushing for natural explanations. They propose that 3I Atlas could have formed in a carbon-rich protoplanetary disk around a carbon star, where unique chemical conditions, while improbable, might allow for the formation of nickel carbonyls. It's a theory that pushes the boundaries of known astrophysics but keeps the object within the realm of the natural. On the other side, a growing number of researchers, emboldened by the sheer number of anomalies, are starting to take the artificial origin hypothesis seriously. They argue the combination of its 40-to-1 nickel-to-iron ratio and mechanical light curve is too much to be a coincidence. The debate is raging on preprint servers like ArcSiv, with some suggesting it could be a probe, a solar sail fragment, or even derelict industrial material from another civilization. This isn't an angry argument, but a rigorous process where every theory is being stress-tested against the hard data. NASA's High Anomaly Classification. Officially, NASA's Planetary Defense Coordination Office, under Lindley Johnson, has flagged 3I Atlas as a high-priority scientific object. While it poses no impact threat, its trajectory is being monitored by JPL's Sentry 2 system with an unusual condition code 9, indicating a trajectory so unpredictable it defies reliable long-term projection. This flag essentially tells the entire astronomical community that all bets are off for where this object will be in the future, making follow-up observations extremely difficult and urgent. Internally, this triggers discussions at the highest levels of NASA's Planetary Science Division about the fundamental nature of the object. It becomes a question not just of tracking, but of understanding. The tension between the cautious public statements and the urgent internal scramble to understand what they are dealing with is palpable. The official line is more data needed, but the unofficial reality is that this object is an enigma of the highest order. So, what is 3I Atlas? Is it a cosmic fluke, a messenger from a type of star system we've never imagined, with a chemistry that rewrites the rulebook? Or is it something more? Is this the first truly unambiguous sign that we are not alone in the universe, a piece of technology coasting through our solar system? The data is tantalizing, troubling, and refuses to give us an easy answer. For now, the truth hangs in the balance, waiting for the next round of observations to tip the scales one way or the other. What we do know is that this visitor from the dark has changed the conversation forever. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our universe. What do you think 3I Atlas is? Let us know in the comments below. Thank you for watching Stellar Tech.